Greetings. I'm once again back at the project, the Ventilator Extender. This project was started in memory of Ilan Shoshani, who passed away about 2 weeks ago after a battle with cancer. We'll start off. How did I get to starting this project? This is, as she calls herself, this is Dr. Charlene Babcock, and she explains how she envisages to connect 4 people to one ventilator. This video got an extremely bad response on YouTube, basically saying to her that you're not saving lives, you're just going to kill people by doing this. I took a look at what she had done, and I decided that that there is a way of making this procedure a lot safer. Okay. A week and a half ago, from Belgium, this doctor, this intensive care doctor, showed how he went out to a hardware store and bought valves to regulate each patient the amount of air that they get from the ventilator. It's an extension what Dr. Babcock did beforehand. She was just connecting the same amount of air to each patient, which creates a problem because not everyone is alike, and some people have got worse lungs and better lungs. This doctor does it in a different way. He went out to the hardware store, bought simple valves. Okay. This is 2 or 3 days ago. Person in India speaks about
In the cases of emergency, if when large patients are there, ventilators are not available, then we thought of a mechanism wherein one ventilator can be used for multiple patients. Uh, Based on the pressure available in the ventilators.
He says it is possible. If we jump to the end, he also says that the medical profession doesn't like the idea and there are flaws of doing it.
The infection from one patient will not be affecting the other patient. Some filtering mechanisms also to be incorporated in this. That also we are incorporating.
Okay. He brings out the fact that one needs check valves on the exhale. Exhale needs check valves so that you don't infect one. Each patient infects one at the next one.
The joint statement came about with discussion when the.
This is a person who. This is a person who represents an organization that was very, very anti the idea of using one ventilator one ventilator on a number of patients. And in this video, he basically walks it back. He doesn't apologize. They make no apology for bad-mouthing the people that were trying to save lives, but he walks back. They walk back what he said earlier, which was that it will just kill people.
COVID-19 took off and we started to see more and more patients requiring ventilation, started to hear about the experiences in Europe. There was
okay, so all these videos are linked from this page. From my page, you can watch all of them. Okay. Here we're going to jump into this video, and we're going to jump in. We're going to jump.
If all of us are calling out sick, there are no more doctors left. There are no more nurses left. I intubated a nurse the other day from COVID-19.
Okay. Due to shortages in hospitals, some hospitals have begun sharing ventilators among patients. This is in a first world hospitals in New York. I'm not talking about New Delhi or Bangladesh or any other country which wouldn't have the resources which are in New York. And believe me, if this is what happens in New York, it's going to be damn sight worse everywhere else. Okay. That is background of where I got to the project. Let's talk about what are the aims of the project. The aims of the project: 1, to measure the pressure at the beginning and end of each breath. That means I'm measuring the pressure in the main tube and each tube which goes to each patient. Not only am I measuring that, I'm measuring the maximum amount of pressure that goes to the lung. Above that, I'm creating a graph of how much air goes into the lung, which could be translated to flow. Okay. In order to possibly reduce the risk that healthcare professionals may have, I wanted to add a way of remotely changing the position of the valve without physically going to the patient. This is a real problem to get 100% fault tolerant, because human error can be that the person intended to change the valve on patient 1 and they changed the valve on patient 2. It is something that I've put forward. It is very difficult to get this reliable and safe enough to be in a medical environment. 5. On the same printed circuit board, I wanted to make 2 types of devices. One device which is first world type of device, where cost is not a major concern, and what you're more concerned about is fault tolerance. To try and make a device which is close to 100% fault tolerant. And on the same PCB, being able to make a minimal device for third world countries, or where the number of people is more important than the fault tolerancy of the system. My goal was a bill of materials of roughly $100. Roughly $100 bill of materials for a basic system. $150, $160 bill of materials for a system which with mechanical changing of the valves, and $200 for a full system. If one goes into it, it's not that expensive a project. Okay, I looked at four different ways of doing the hardware for this project. One, I assumed that I'm going to be using an expressive ESP8266 or ESP32. The ESP32 has substantially more features. It's worth an extra $1. Okay. When I started off looking at the design, I started off trying to design only using brand name parts. Brand name parts means mainly TI. For that, I designed using INI 326 as my instrumentation amplifier. From my website, one can take a look. The link is there. It'll take you to the circuit diagram. The circuit diagram is almost 100% fault tolerant. If you build with all the parts, not half the parts. Okay, I then decided that it is a lot easier and it's a lot more logical to use a custom chip which is designed for a bridge measurement amplifier. A chip which you generally find in a scale. The chip is an off-brand chip, an HX711. Okay. As it's off-brand, the chances of getting this chip passed via FDA close to zero. Okay, it's a very popular chip, but I'm not sure if it will. Okay. Where did I go from here? Okay. I took this HX711. I used the open source documents from SparkFun to import their circuit diagram. I removed the parts which are not relevant, as the sensor is all the time powered up, I don't switch off and switch on the sensor. So that was removed. Okay. I evaluated another two options for chips. One is a chip via Novaton, and the chip via Novaton, my problem with it was, once again, it's also a Spark Fun. They also make a product using it. NAU 7802. The 7802, I pushed it out because it uses an I2C bus, and an I2C bus is not reliable enough for a medical device, especially if you're going to have 8 devices on the same bus. It's just not reliable enough for where I wanted to put it. It would have been a nice option if it had SPI, but it doesn't. Okay. One of the feedback I got last week on LinkedIn was to look at more upscale sensors. Upscale sensors have already got the analog and digital conversion within the sensor. And I looked at Cenicron, and I looked at Cenicron, and I looked at their prices from DigiKey, and I looked at the prices from LCSC, which is the cheapest possible way that you're going to be able to get this device. Okay. The cheapest I can get this device is around $20 to $26, a sensor. This is from China, from the cheapest possible, even in quantities of 100. If I go even to quantities even more, 1,000, still $25 a device. If I'm using NXP, if I go to this first sensor, I still need an analog output. The first sensor is not a digital output, it's an analog output. This was too expensive. It was too expensive to create it. If I need 10 sensors, that's $250 just on sensors. And once again, I want to have the whole system for $200. The NXP sensors, shall we say, they're relatively old sensors. They're Motorola sensors, which is currently NXP. Okay. Seem most logical. They seem just most logical way of doing things. Okay, if we're going to start looking at the link for my circuit diagram, my circuit diagram has the stepper drivers on the left. It has circuit diagram for mechanical feedback at the bottom. Here are the sensors. The sensors are going to the custom chip for measuring bridge, Winston bridge devices, and it's a 24-bit output, which is 8 bits more sensitive than what I would have got on the $25 system. It's a no-brainer that this is the way to go. The downside is the measurement is relatively slow. It's either 10 hertz or 80 hertz. Once again, I'm not going for advanced. All I'm on a 4-second wave. 10 hertz is more than good enough. 80 hertz is wonderful. If I wanted to get from this measurement to pull out how many breaths, heartbeats, I wouldn't be able to do it because I wouldn't have the Nyquist resolution for that. But for what I'm planning on measuring, it's more than sufficient. Okay, here we have analog muxes. Analog muxes get the position data, both position data and backup position data, and the measurement of the voltages going to an ESP32. There are 4 channels. There are 4 channels with the custom chips. A simple power supply, once again, with redundancy and with feedback. You don't need to use double the parts. You can put in jumpers. There's no reason not to. Okay. Going further. This is a 3D model done on Thingiverse for what I assume to be which would be able to do the linear actuator to set the position of the valve remotely. This is the Thingiverse link. This is somebody that made the product. I cannot use this type of mechanical feedback because I need to measure the exact position and not how the movement is. If for some reason the system is switched off and or you miss pulses or some type of counts, you don't want to do it. I need an analog value which will tell me the position of the valve. Okay, which would mean that this 3D model would need it to be adapted for what we're doing. Okay. Thank you for your time. Unfortunately, I did not want to do this project by myself. I wanted to do this project in a team, and if it was a team project, I'm 100% sure that this project could have been done within a day or two. There is nothing in this project which is extraordinarily difficult. There are areas which are somewhat more complicated. For example, I have not started any code. I have not started any software coding for this project, which it would be a lot easier if somebody else did, as well as the mechanical 3D side of designing the actuator with feedback. What's more, I've only placed the parts, I haven't routed the board, which makes the project at this point in time, it's going to take me a very long time if I'm going to do it myself. And unfortunately, I don't see anyone stepping forward to joining me to save lives. Unfortunate.